Alright, lazy Sunday, gonna solder a kit. Let's see what we got here. Should I pick one or pick one at random? Let's, How about this roulette wheel? Let's do that one. I think that's what this is. Looks like we got no instructions, so we'll just have to go with it and see what happens. I'm going to use this to organize my components. Is that in the way? Is that, yeah, get these out of the way. Pull this closer to me so that I get everything in shot. All right. It's not for this. We'll do a looks like we got some caps. Some kind of chips. SMD chips, resistors, a diode, a transistor, some kind of header, a button, a bunch of LEDs. Why did they make the LED surface mount? And more resistors. Alright, should be pretty straightforward. Looks like we got two different values, 47 microfarad and 1 microfarad. And I guess they're going to go one. They're all labeled. It's a good idea. If you make a kit, make sure you just label the silk screen. This is a 1003. And this is a 470? 474. Alright, so 470K there and there, 10K there and there. Right, 10K. Oh, I see one 10K on here. 470, 470, 10K. Yeah, looks like they gave you two, just because it's probably hard to cut one. And switch, battery, two ICs, and transistor in the middle. Alright, so I guess I'll put this on here. We'll do the surface mount stuff first. I guess I'll hand solder this. I mean, what's the point of watching somebody hot air if you can't hot air, right? And we'll just make sure I keep adjusting this. I'm gonna try to not get my head in the way, and I think I'll stay zoomed out, or should I zoom in? I might zoom in for the SMD stuff. I'm just gonna use this big tip, big wedge, standard wedge. I'm not gonna use any small tips. We'll just see how this goes. The first thing we want to do when you get a board like this, when you don't know where it's coming from, and it's not sealed, is you probably want to clean it. If I can get these, I need to make a holder for these. You probably want to clean, probably cut some of these in half. I don't need that much. Just clean it with some IPA, some alcohol, vodka, whatever you got. Make sure there's no oils on it. That's just ISO 70%. That's purple. I don't know why I put ISO, not IPA. Same number of letters. Alright, so I guess we'll do these ICs first. I think last time it came out better if I put it on here. If I put it like this, then I can get it up higher. Problem is moving it around. So we'll try to leave that and center this. I wonder if this will work better on the other side. Yeah, should be fine. Alright, so we'll just do it like that. Should I zoom in? Alright, so I got my iron on 700. I usually keep it pretty high. If you're new, you don't want to do that because it might take you a long time to solder stuff. I also use this thin solder. I forget what size this is. I'll look at it later. I always forget the sizes. Some of them are in millimeters, some of them are metric, some of them imperial. So it looks like we got a NE555, and maybe this is some kind of, it's a 4017. So we're probably generating a clock pulse and then feeding this, and this is probably a counter, and it's going to count. And then maybe they're using a capacitive charge to disable, to turn off the enable so that it stops randomly. I don't know. Let's check it out. I don't have any through-hole LEDs, so I'm gonna have to use just these red ones. I wish I had some water clear ones that were better. Actually, I do have some, but I have to find out where they are. Well, let's just start with this. So for SMD, you want a tin one pad. I'll just go ahead and tin this one over here too. And one of those, one of those, one of those, and one of those. All right. Oops. All right, so the first thing we're going to use is, let's see, we're going to put the bigger, should we put the bigger things on first or the smaller things? It's a tough call. I might actually put this transistor on first because it's going to be hard to get in there if these components are there. Same goes for these. So let's do that. Let's do the transistor first because it's right in the middle of the board and it's going to be hard to get in there. You just want to peel that tape off and just plop it out. And then this is probably the worst way to do this because I did it backwards. I'm going to flip that around. Make sure we're still framed. Yeah, that's going to work better actually. Alright, see, I use these gullwing or whatever scissors, tweezers. I use these gullwing tweezers because they let you don't have to hold your hand like this. You can just keep them straight. It's a little easier to work with, and then you can rest your hand if you need stability. Sometimes I need stability. Haven't been very steady lately. I used to be extremely steady, but I've had some problems lately with that. Some weakness going on. That and allergy medicine and caffeine doesn't help. So you want to heat that ball up and just push that into it. And don't let go until it's secure. And sometimes it's not really secure, so you make sure it's not jiggling. And it's not dead on there, but it's good enough. I mean, you don't want to move it because it'll break it. But that's going to be good enough to solder. And then you probably want to rotate your material so that you can hit it from the right angle. And then we're just going to touch that one. Oops. Ugh. Sometimes it's hard to get your iron in there. Shit. This has proven to be a problem. I don't know why. Maybe I didn't put it on there straight enough. There we go. Looks like this board might have needed some flux to flow first to get it to stick. So I'll remember that. That's pretty messy. But I think it's electrically secure. I think. I think it is. Alright, looks like we're good. That's really, I don't know if that's connected. It helps to have like a little magnifying glass, or you can always use your phone. I got this one, it's a lighted loop. You don't really need a lot of solder with surface mount components, as long as it's, you don't need to have a bead. As long as it flows underneath it, you're good. This is just a lighted loop. And that helps for inspection. If you're doing SMD, I also have some of these. It's like a 15x, a 10x loop, just different kinds. But it's hard to see unless you have light. You can put some light in there. Otherwise, you can't really see what you're looking at. So we'll take a closer look at this later. I don't really have a macro lens, but we could figure something out. All right, next. And you might want to do your passives first because they're more forgiving for heat until you get warmed up, until you get used to what you're doing. And you know, you can solder these and unsolder them and resolder them, and you won't really damage them. Just don't let them stick to your iron. I'm kind of scraped. There we go. I think this is the 10K. You can tell by looking at it, it's got the little numbers written on it. 1003, that means 10. 1003 means 10 and 3 zeros. So for 10K, for this resistor, we're gonna hold it. Again, we're gonna heat this side. Oops, slide it in. And then hold it until it sets. It could take a couple of seconds to set if you're using leaded solder. So don't jiggle it around. You maybe can use different solder for that. If you're starting out, you can use a lower temperature solder that stays liquid longer, and you can heat it up and then slide it in and not have to worry about that. So that was enough solder to do it, but you really want to just hold it for a second. Don't hold it too long because you'll unsolder the other side. The heat will actually go through your component and heat the other side, and it'll come right off the board. All right, so I'm going to do this chip now. Since it's in between those two components, I don't want to do any more. Doesn't really matter. This is the 555. That's weird. It's got some kind of pattern over it, so you can't see the chip. Some of these are static sensitive. This is probably CMOS. It's highly unlikely that modern CMOS will blow out. You want to look for the pin 1 marking. It's usually a notch or a line or a dot. This one actually has a line and a dot indented into that first pin. So that lines up with the notch. Pin 1 will be over here. So that goes that way. So whatever you get a notch, a dot, or a line. Sometimes these chips are beveled on the pin 1 side. This actually has all three. It doesn't have a notch because it's so small. SMD chips don't really have notches like dip packages do. Alright, so I'm going to hold this here. This helps to do this on the table so that your arm is supported. I'm up in the air. It's not the easiest thing to do, but it's easier for keeping my head out of the way and for soldering for the camera because it's closer and because I can move it around easier. So we're going to heat that and then slide it in. Oop, see, it's not grabbing. I wonder why it's not grabbing. It's kind of floating. Alright, so sometimes you'll solder one side and it's not exactly perfect on the other side. You can just real gently line it up. And then you want to hit something opposite or on the end so that you don't reflow that one. And that's enough. Just touch it and you can pull away. So I'm going to go to this side. I'm just going to keep rotating this because it's hard to solder at an arm's distance unless you keep the part moving. So there's one. There's another. There's another. There's another. Clean your iron. And that should be good enough to hold that chip. It should be a good joints on all of those. Another option is to put some flux and just go across the whole thing with solder. But sometimes you'll get some bridging and you'll need to clean it up. But you can see I'm using a fat tip. And I already put too much solder on there, so you want to pick it up with the soldering iron and get it off there. And I'm going to redo that first pin to make sure it's really good. Alright, so that chip's on there. U1. Now we're going to do U2. Microchips are U, I guess, for micro chip. Sometimes they're IC. Usually it's U. Resistors will be R. Capacitors will be C. Inductors will be L or I sometimes. Usually L. Transistors will be T or Q. Usually Q. And switches S1. LEDs don't really have a numbering. They're usually diodes, so they usually just put a D for diode. LEDs are technically diodes, so usually how they're identified. Alright, so let's see what we're doing here. If you can't get your chip to flop over, turn the right way, usually just drop it. So here we go, we got this line and this dot, and this side is beveled. See it? Beveled. There's the notch, so pin 1 goes top left. And this might be a little hard because it's a wider, well, my tweezers hold it, so I'll do the same thing here. Make sure it's flat. You don't want it flapping in the breeze. You want to make sure your chip is flat on the board. And that's why you want to slide it in. If you put it on top of there, then you're going to have pins in the air, and it's harder to solder. So there we go. That's dead on. For this, do we want to... I'll drag solder this side. I don't know what kind of solder I'm using. I just know that this is the smallest one I have. We're going to tack this guy over here. Going to do each one. Just keep your solder iron clean. You don't want to get a buildup of solder. If you get a bead on the other side, it'll bridge your stuff. It's easier. It's better to waste solder than to have to undo a bridge. If you have to undo a bridge, you might need to resort to solder wick, which is like actually I have some right here, which is this copper braid, and you put it down, you heat it up, and then you pull all the solder back up, and it helps to put some flux on there too, just some no clean flux. I just bought that and filled up a syringe with it. Alright, make sure your iron's clean. You want it clean at all times. So I'm going to spin this around, and then we're going to make sure we're recording. And for this, I'm just going to put a bead of solder on here and just drag it down. And then drag it out. See? You're dragging out so you don't drag across the pins. And every time you put the soldering iron, if you have a clean soldering iron, it'll pull up some of the material. Whatever doesn't stick to the other side. So if you have a bridge, that's a good way to get rid of a bridge. It just takes a little while. So those all look good. You see, and I wasn't so meticulous about that. I just kind of blip and then pulled it off. And you know, if you want to inspect that, you want to go in and before you power it up, make sure all your pins are good. Some of these chips can, you know, blow if you don't have a pin soldered. And with something like this, with SMD, you want to avoid dwelling on a joint, because not only can you break the you burn out the package, but you can actually pull up the traces on the board or just burn the solder mask, and then you could get shorts and stuff like that. So, you know, the best thing to do if you mess up is stop, let it cool down. Don't just keep hitting it. Just don't keep trying to do what you're doing. Just, you know, people get frustrated and they just keep globbing solder on there. Stop what you're doing. If you have a whole bunch of solder just globbed all over it, don't freak out. You don't have to get it off while it's hot. Let it cool down. Let the chip cool down. Let the board cool down. Especially these cheap Chinese boards. These are made for pennies. These aren't like commercial PCBs. Sometimes these are very cheap, and any bit of heat on that pad will cause the whole pad to rip up, and then you can't do anything. You'd have to repair it, which is not very easy for a beginner. With that, you might even need a microscope. So just calm down, relax, let it cool down to room temperature, and then go in there and start pulling solder off. If you have a solder wick, hit it with the solder wick. Make sure the solder wick is hot. Don't drag it, or else it'll stick and pull a pin off and pull your copper off. You want to put I guess I could demonstrate this. I guess I could demonstrate this over here. So I put too much solder on there, so I'm going to put an unused piece of copper there, and then I'll push down on it and let it get real warm before I start moving it, and then pull it off. See, it pulled all that solder off. We'll do the same thing over here. Pull that solder off. So now I have a clean joint. Now you want to be careful too. You don't want to sit there and go too long. I also want to let that cool down before I start soldering on it, because I can pull those pads up. So that's the big thing. Take your time. Don't use a 100-watt soldering iron and just blam it in there. If you don't have a temperature-controlled soldering iron, just be real careful. Use a little transfer solder to your soldering iron, and then place it. Transfer solder to your soldering iron, and then place it. And then you can really control how much you're putting on there. As long as you get flux on there first, it should work. But that's not really how you solder, but sometimes that's how you have to solder. Especially if you don't have room. Alright, so now that we're up to these, we'll go ahead and put that resistor on since we're already there. So I'm not going to do that 15 times. I can take that off, screw it all up, take it off, put it back on, take it off, put it back on. As long as I don't overheat anything, I can keep redoing it. I can do it all day. And if you have to, turn your iron down if you're going to be messing up, I keep my iron hot because I like to get in and get out. It causes less damage. Ultimately, it causes less damage because you would think that the higher heat is more dangerous, but lower heat in a longer time is just as bad. Depends on your soldering skill. If you're fast enough, then so that's a little floating there. I'm gonna have to take that down. This is kind of up in the air. I can't get it flat. So I'm going to heat that up and then slide it in. And you'll be tempted to just solder one, stay on one side of the board and solder that one, solder that one, solder that one. But if you have two things that are close to each other, like these might share a pad, when I go to solder this one, it could unsolder that one, and then it could go all over the place. So it depends on if you know how the board's laid out and you're keeping things far apart. You can do that. You can do one side, one side, one side if you're placing a lot of components. But you really want to just stick to one component at a time, because if you have any heat over here that flows to this joint and unsolders that, then your stuff's gonna move, and then it's gonna be a real pain to clean it back up. You're gonna have to. See, I'm tempted to put that on there at the same time without rotating this. But I'm not going to do it. I'm going to make sure that's soldered on both sides. And you barely need to touch your solder. It'll wick right to it. Not like solder on through hole where you have to feed it in. SMD, as soon as you touch it, it pulls it right onto the component. Alright, so this other one, I've never actually soldered one of these. Oops. Never actually soldered one of these. This is a glass SMD diode. I can guess you have to be careful with these because they're round. They're probably going to roll all over the place. For diodes, I believe so this black mark should be the line on the diode, or the cathode. Cathode? Negative, I believe. I need to get a good mnemonic to remember that. All right, so I think that's right. So we're going to just try it the same way we do other components. We're going to heat that up and then slide it in. Whoops. Let go. And don't worry about getting a good bond on that. As long as it's on there, you're good. Because you can go back and redo it. In fact, you always probably want to redo it. Let's see, if you have to hit that a couple times, just get a feel for how molten it is. And just keep hitting it. I don't want to do that for longer because the heat will go through the component, either burn it out or melt the other side. And in fact, that's how you desolder components. You put some flux on there and you can just heat both sides at once. The heat will go across and you just pull them right out. You just pull it off. Alright, so that's on there. I guess I need to figure out what voltage this thing takes. Oh, I got one more 47K. Right, 470K. I think it's this guy right here. And these are pretty big. I mean, once you get used to SMD, these are pretty big. These are 805s. Which is, you know, you can pretty much use without a microscope, without any vision enhancement, without any magnification. Now you can get 1206 components. They're a little bit bigger if you had a hard time working with these, but it's harder to get. They're actually more expensive because they're not used for mass production anymore. They're rather large. In fact, they're using 2.0 really tiny components now. Hopefully 803s stay around for a while, but they might go away sometime. That wasn't the best solder joint there. It's not really centered on the pad. But instead of messing with it, I'm just going to leave it. Alright, I think we're done with the surface mount. Let's get to the through hole. Should I take it back out? Yeah, we're doing through hole. We'll zoom back out. Just to make sure I have a good recording in case it dies, in case I fill up my space. Alright, so for through hole, we don't need this. I can get rid of this. And we can either put the board in here. I might do that. If you don't have a holder like this, it's not a big deal. Just put it on your bench. Just have something to hold it down, or give it some weight so it doesn't flop around. So we're going to do these capacitors here. This one is a 47 microfarad. On a capacitor, the one side will have a band. It's the negative side. Here's the little plus sign, so that goes on the other side. 47 microfarad. Here it is. Positive. Also, one leg will be shorter. That's the negative. If there's no marking. Usually there's a marking. And for through hole components, I usually just bend them. Oh, that's not a capacitor. Where did the other capacitor go? There it is. This is a 1 microfarad. Again, short leg, negative, positive on the silk screen. Usually it'll say positive, or one side will be shaded. That's the band part. Positive, negative. Double check, make sure you're right. I don't know why they didn't use through hole capacitors. I mean, I guess they're more expensive for the price point. It's kind of silly that they used. Bend the leads and then just flip it over, and you could do multiples at once. And for this, I'm going to use a thicker solder for the through hole. And capacitors, you don't want to overheat. Same thing, you want to hit it. Remember, just because you overheat one lead doesn't mean you can go right to the other one. This is connected internally. If you spent too much time on that one, you want to let it cool down before you hit the other one, because the heat's just going to go to the same place. And you could burn something out. Alright, so then we're going to take a pair of diagonal cutters and just stand these up and cut these off. Watch your eyes, eye protection, or make sure you're holding your leads. I like to cut them down so they're not sharp in case I want to put this on the surface of something. Not punch holes in your whatever. Alright, and then there's a switch. We'll put the switch in. Switch goes, I think it goes this way. It's hard, yeah. Oh, 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 don't drop it. Switch goes this way. And then there's a header. For headers, you're going to have to hold them while you solder them, and I'll show you that in a second. Alright, so for these, for the switch, I'm just going to hit it. For big stuff like this, you might need flux. This button might be dirty, but it seems to be soldering just fine. That's also why you want to use bigger solder, because it has more flux. Alright, so that's in there. And that works. Alright, so to put this header on, we are going to, where is my, I'm going to use these, I have these locking tweezers, and that's what I use usually for soldering headers like this. So I'll put it in there like that, and then I'll secure it with the tweezers. And then I'll solder one side. Then take it off. And then hit the other side. And you can use your fingers, just don't hold the pin you're soldering. You'll be amazed how fast that heat travels through it. Another option is to use something that plugs in, and use that to hold it. Use a DuPont connector or whatever, and just jack it in there. Alright, so it looks like it's done. The only thing we got left is the LEDs. Let me, we'll just use these red LEDs. I'm not going to replace them. I'm not sure what I have, so I'd have to test them, and we'll just go ahead and solder these. Alright, so with the LED, I believe the short leg is the cathode. So I believe it goes with like that. They also have a little one side of the round piece is ground down flat. Sometimes these footprints will show you which one that is. I think that's right. I'm gonna go ahead and put these all in. I think that's correct, but I'll wait till my computer boots up and double check it. Actually, I have a. Oh, it's already. Why did my computer crash? That's really strange. My computer's never crashed. Right, so the short leg is the cathode, which is negative, which is the same as the ground edge. So the ground edge, the side that's flat, when I say flat, the bottom of the LED is a circle, but this side over here is flat, and this is the short lead. And so the flat side is the same as the chopped side with the arrow with the line across it. So we can go ahead and put these all in the right way. We're not going to put too many in because it's going to be hard to solder around them. We'll just put them all the way in. Sometimes LEDs have these little little pieces on their leads, so you might have to push them through the hole, you know, a little harder, or finagle them until they fit right. So we're gonna bend these in opposite directions because we want our LEDs to be straight. So we're going to take care to bend these and make sure they're fairly straight. And so we might want to just do one side and then do the other. So we're just going to heat. Let's make sure that we did them all right. Yeah, make sure they're right before you solder them. Just like measure twice, cut once, right? So then we're going to make sure that they're all straight. They're pretty straight to me. I'll solder the rest of them. Oops. Your instinct might want to be just keep seeding solder into it if it's not taken, but when it does take, you're just going to have a ton of solder on there. So just make sure you're heating both surfaces, the lead and the pad, and that'll get you going the best. I like to bend these back so that they, if you have to desolder them, they're not hooked. They don't come out of the board. I mean, they're already bent in the hole, but if you get them closer to straight, when you cut them, you won't be left with a little hook that makes it hard to remove. I'm just going to cut, again, I'm going to cut these flush so that they, you might want to not cut them flush until you test the board and then do a final trim, because when you cut them that close, it's hard to desolder them. You think it'd be easier, but it's actually harder because you have nothing to heat, to get the heat into the hole. All right, so flat side goes. Yeah, whoever designed this board did us a favor. They put all the LEDs in the same direction. That certainly helps us. Certainly helps us. And, so you can see these holes are a little tight because they hit that right there. All right, I got two more. I'll do those last because they're in the jaws. All right. When I used to do a lot of through-hole components, I actually had a jig I made that had like a foam sponge that would push. You could clamp it down. It would hold all your components, and then you could flip it over and solder them all. And when you used to do a lot of through-hole stuff that helped a lot to have something like that. And there are commercial products that do that you could still buy that are made to they have like a rubber silicone plate that goes down and you flip the board over, and that's made for doing large boards, like if you're doing an old analog or discrete computers and stuff like that. I don't care about straightness. I'm just going to get these soldered. It's easy enough to fix them. Of course, I do want to check them before I cut the leads off. Make sure they're all right. And you'll know one's not working because it'll be off. It won't light up. And these are fairly cheap cutters. You can get these for $4 or $5, I think, on Amazon. You don't have to get fancy ones. You're going to destroy them anyway. No matter how good they are, they're going to get ruined. You're going to cut stuff that's too thick and it's going to leave little gouges in there, and this just happens. All right, oh, 2 more and we're done. All right, so that goes. Oop, those ones are different. Those are not aligned the same. Those point in. And this one goes flat on that side. No, oh, y'all, they're all right. They're all pointing up. I forgot I rotated the board. And you know, another way to do this is to just hold it while you solder it. But you gotta be careful you don't burn yourself. You will burn yourself. Have some burn cream. When you learn how to solder. Now and then I'll still burn myself. I'll forget what I'm doing and I'll just like grab something that see now this one's crooked, so then you can kind of know which way they gotta go and just move it a little bit. There you go. This one. Another option is just to leave enough space. Don't push them all the way down to the board. And if you leave a little bit of space, then you can always just bend them afterwards if you're really not really worried about the final appearance. Oops. All right. So, and also watch these things. These little metal things go everywhere. You don't want them in your circuit, because it'll blow up. All right. So now we do a visual inspection and make sure we did everything right. I'm just gonna put that over there for now. Leave our soldering iron on. 470, 10K, 470. Transistor looks a little wonky, but I think it's okay. It's a little messed up. That transistor doesn't look too great. And you can see, you know, this is that one I didn't do perfect. It's kind of off the pad, but it still bridges. Still works. You can see my ICs are soldered fairly well. That pin doesn't look too great, but looks pretty good to me. That one. That one. You can always look at it from the side, make sure there's no bridges. Make sure there's solder underneath the pads. That one looks good. See, it's shiny. That one, that side. So it looks like it's got a hole in it, but that should be okay. That's got a little too much solder over there, and you can see that transistor is completely off the pads. But they're soldered, so should be good. Alright, so let's take a look at this and power it up. I don't know what this takes. We'll turn my soldering iron off because it's making kind of a buzzing noise. Get it out of the way so I'll burn myself. I shouldn't need to solder or anything. Everything should be okay. Alright, so oh shoot. I need to make some plugs that are female. I guess I could use I'll just use female to females. There we go. That'll work. And we'll do blue is positive, white is negative. That'll work. And then we'll hook this up to negative, positive. Get in there. What's wrong with this? I always get a darn connector that doesn't work. That's good enough for now. I'm going to throw that out or fix it. It's messed up. All right, so there we go. Let's power this up and see what happens. We'll start off at, I guess we'll do like 100 milliamps, 3.3 volts. I've got a light lit up, one. It's not pulling any current. It's pulling like 1 milliamp. Doesn't appear to be working. So how do we troubleshoot this? Well, let's double check what the voltage needs to be. We'll do LED Roulette kit image search. Hi, this is by Julian.
Good morning all. Today I thought I'd build this.
You just put a 9-volt battery, it looks like. Maybe I just need more voltage. I mean, this could be TTL. TTL goes up to... TTL can go up to, what, 12 volts? Alright, so we'll bring this up to 5 volts. Nine volts. Nothing. We got nothing, buddy. And it doesn't work. Negative. 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 470. 10K. Transistor. Diode. Alright, the next thing we would have to do is find a schematic and find out what these pins need to be, or what's going on here. Since it's not doing anything, I would assume that I mean, I could have put the button in backwards and it's always shorting. No, looks like it's right. Ground. I don't understand what this button does. I don't see any vias there. Oh, it's on the top side. Goes through that diode right there. So I guess we'll pull out the multimeter and test some stuff. Was really not in the mood to do this today. I was hoping it would just work. Alright, so we'll put this on continuity and we'll just start testing stuff. I mean, obviously it's getting power. We got I really don't know what to do here. Everything looks fine. I'm going to guess something's burnt out. Something's not working. Alright, so I turned the voltage up to 9 volts. And a different LED seems to be lit now. But I don't know what is going on here. See? So if I had to guess, I would say that the 555 is not oscillating. Because whatever the pull down, whatever the enable is not working. So let's look at this pinout and see what's going on here. 555 pinout. If I had to guess, I'd say it's this transistor. Could be the wrong transistor. I'll almost bet the problem is with this transistor. It looks like this transistor has ground. I bet that transistor's bad. Problem is it's in the middle of the damn board. I can't get this to work, so I'm gonna have to give up. This really sucks, but this doesn't work right off the bat. Just waiting to heat up. And I pulled that pad right off the board. Well, now it'll never work. So that could not get that off. I pulled this little pad right here off the board. I exploded that transistor. Alright, that might be, I might be able to fix that. Well, let's plug it up and see what happens without that transistor on there. Nothing. The diode is just for, probably just for reverse polarity protection. Switch pulls down the base. Pulls up the 10K. So if I go in here and pull up the 10K, this side, look at that. Okay. Okay. Well, it works. I think that diode was bad. I'm gonna try to put another diode. Not diode. Try to put another transistor in there. I think I need a PNP though. I don't. Yeah. Wait. This one's an NPN. This one says NPN. What? Let's look at this. Let's look at this guy and see if we can see anything on there. If I can clean this one up and read it. I think it says J6. So let's try to resolder a new transistor. See if it fixes it. So I'm just going to grab an MBT 2222. Unplug that. We'll grab one of these guys. Oh, there's one right there. All right, perfect. I should just put surface mounts on there. Diodes and capacitors, just bridge them. All right, so we're going to put this guy over here. We are going to solder that broken one last. Alright, because this last one is broken. But we can always fix it if we have to. Shit. Alright, we're just going to barely touch that. We don't want to delaminate it any more than it is. Oh, that sounded that better than before. Alright, so word of advice, don't start off soldering SMD until you're used to it. Start with something real simple. No. It's working! We fixed it. I guess I burnt that transistor out when I was soldering it somehow. So it works now. That's weird that it seems to narrow. That might have to do with the frequency. Why does it not spin and then stop? I wonder why it does that. Shouldn't it just keep spinning? Why does it not show it spinning anymore? Is it a persistence of vision thing? That's strange. I thought it would spin in a circle and then it seems to jump around a lot. It always winds up with the same one. So something's still wrong here. This is interesting. Let me turn the voltage up and see if it has something to do with the voltage. Maybe I burnt something out. They all seem to be lighting up. Okay. I guess Capacitor just wasn't charging right. It's weird that it narrows and doesn't just keep circling until it slows down the. Well, I guess it won't slow down. It's interesting. Not what I expected it to do. Pretty cool though. I'm glad I got it working. So that's it for now. So maybe I'll do a video about what's wrong with this thing. I actually did some further debugging on it and put it on my scope, and we'll see. There seems to be some kind of jitter on the last clock pulses from the 555 that's causing that.